I guess we started solids, right? Am I right? Or we are doing still system of particles? Can anyone reply, please? Solids we started. Am I right?
Yes, sir.
Yes, sir.
Topic is properties of solids. What are the things we need to discuss on it? First thing is stress, strain, modulus. This is first thing. What is stress, what is strain, and what is modulus? Right? Then types of stress, strain, modulus. Types of stress, strain, modulus. Next thing is Poisson's ratio. Next thing is relation between E, G, K, mu. This is next thing. E, G, K, mu. Next thing is strain energy. Strain energy stored in a rod. Okay. Next thing is thermal stress. Okay. One more thing is, so thermal stress I will just replace here. Before that I'll write stress strain graph. Stress strain graph. So this is the order. First part is stress strain modulus. Second part is types of stress. And third part is Poisson's ratio. Fourth part is relation between EG mu. Fifth part is energy stored in rod. Sixth part is stress strain graph. Last one is thermal stress. Okay, these 7 parts we need to cover in this topic, properties of solids. It is first topic in volume 2, whether it's CBSE or state board. Topic name is properties of solids or simply solids. Right? For NEET exam, you will get 1 or 2. For JEE, you will get 1 question. No? This is weightage and overall skeleton of the chart, properties of solids. Okay. This is weightage and overall skeleton of entire chapter. Okay. Now we'll deal in our regular style. What is what? What is first one? Stress, strain, and volume. Stress, strain, and modulus. What is stress? What is strain? And what is modulus? Can anyone say either orally or chat box what is stress, strain, modulus? I guess this chapter is already completed in your regular school, right? Just type in chat box. எந்தெந்த ஸ்கூல்ல ஏற்கனவே முடிச்சிருக்கேன் just reply with yes or no. டாபிக் முடிஞ்சிச்சா இல்லையா just type yes or no. yes னா முடிஞ்சிச்சு no னா முடிக்கல ஸ்கூல்ல நம்ம கிடையாது உங்க ரெகுலர் ஸ்கூல்ல
Yes, sir.
okay only one student out of 36 comment can say orally or type in chat box. Am I audible to all? Any problem with my
What
audio?
unit area is this?
It's okay, we know, but most of the people are deaf and dumb. What happened? Am I audible?
Yes, sir.
If you're not audible, if you don't have any interest, I'll close the session. Can I close the session?
No, sir.
No, sir.
No,
No, sir.
No, sir.
I should understand whether you are listening or following or not.
When after the removal of the deforming force, when the body regains its original size or shape, it's known as stress, sir.
Okay. See if you
It
take
does
a
not regain its size, strain.
that property is called elasticity. If I applied a force on it, if I apply a force of 10 Newton here, now this is the area where I'm applying force. So suppose this is some 2 meters square. Area is 2 meters square. Okay. So if I apply a load on this rod, if fix this, if I'm applying only one side, now what happens? It elongate. Let us say the elongated part is this. This is elongated part. What I mean to say, black color part is original part. Original or actual. Let me give its length. Its length is 10 meter. Okay. The blue color line irka. Either, let us say, 20 meter. 20 meter. Now the question is, what is change in length? Change in length is obviously 10 meters. Let me change it because again here 10 is there, you may get confused. Let it be 18. For easy understanding purpose, let it be 18. Okay. Now what is change in length? 8 meters. Okay. Now see, what is stress? Stress is how much force you are applying on what area. This is what stress. Right? What is the definition? How much force you are applying on what area? How much force you are applying on what area? That is what stress. This is the meaning of stress. Right? Now what is strain? Because of application of stress, what are the changes?
Change by original size.
Right? So change may be in terms of length.
Volume.
Very good. Area or volume. Anything. What are the changes in terms of length, area, and volume? Next, what is modulus?
Stress by strain.
Very good. Modulus is nothing but stress by strain. In layman language, it tells us. In layman language, it tells us the strength of a body to bear external force. Strength of a body to bear external force is called modulus. So these three definitions, what is stress, what is strain, and what is modulus, these are basic things of the topic solids. Stress, strain, modulus. Stress is force by area. For this formula is force by area. For this formula is change by origin.
Change by origin.
For this formula is, as you know, stress by strain. This is formula. Okay. So most of the time we'll focus on lengthwise. If I apply on lengthwise, formulas will be like this. It is stress order representation, force by area.
Eta by change by original.
It is strain order representation, dl by L. Stress by strain is equal to
Gamma.
Gamma is rigidity modulus. Now we are talking about lengthwise. Because I drawn a diagram there. Rod So obviously it is lengthwise. Okay, for lengthwise, stress is force by area. Strain is change in length by length. Stress by strain is Young's modulus. In the E irka, that's Young's modulus. Okay, if I substitute stress formula, strain formula, and E, I'll get like this: F by A divided by strain and inner dl by L is equal to Young's modulus. If I rearrange this, I'll get a new formula. dl is equal to FL by A. It's a new form. Here on point to be noticed, if you look at Young's modulus, look at Young's modulus. Is always fixed. It never depends on local dimensions. What is the meaning of that? If length, area, volume is changing, Young's modulus never changes. It is fixed. Young's modulus is always fixed. It never depends on local dimension, right? If I increase the length of the rod, if I change the volume of a material, if I change area of some particular object, Young's modulus never varies. It is always fixed. Okay, but what happens? Young's modulus is fixed, but it depends on temperature. Young's modulus depends on temperature. Young's modulus depends on temperature. How it depends on temperature? First of all, what is modulus? Strength of a body. If I heat a body, will its strength increase or decrease?
Increase, sir.
See, strength and a balloon. I'm giving one rod to you. I'm asking you to bend. Now I'm heating it. I'm asking you to bend. Which case you can easily bend? Heat case or normal case? Which case you can easily bend the rod?
Heat.
Why? In normal case it has more strength. If you heat, it loses its strength. That's why you can easily bend it. If you heat, it loses its strength. Hence, you can easily bend. Deform the shape. Yeah, you can easily deform the shape. So from this story, what you learned? With increase of temperature, Young's modulus will varies. How? More temperature, less Young's modulus. By heat temperature, material loses its Young's modulus. Please keep it in mind. I hope you understand all these things. Now, based on this, we'll do some numerics. There is a rod. Data is given like this. Length of the rod 20 meter. Young's modulus is 2 into 10 power 6. change in length is 5 meters. Find stress. Come on, all of you, please do it. I'll give 2 minutes time. I want stress. Information is given as shown. Length is given, E is given, DL is given. I'm in need of stress.
Five into 10⁵ nm minus 2.
Okay, very good. We'll check C. For all this question, first you start with the stress equal to force by area. Strain is equal to change in length by original length. Stress by strain is equal to is more or less real is equal to FL by A. These are 4 formulas. It lengthwise, these are 4 formulas. Right. Now what I need? I'm in need of stress. What is stress formula? First formula. Force by area. Now force is not given, area is not given. Where I get stress? Stress is also given. So select that thing. Stress by strain is equal to Young's modulus. What is strain? DL by L. That I know. 5 by 20. That is 1 by 4. Right? So from this I can write stress by 1 by 4 is equal to Young's modulus 2 into 10 power 6. Take this 1 by 4 here. 1 by 4. 2 into 10 power 6. By the final answer. Unit is Newton per meter. If you further simplify, this is 2 by 4. That is 1 by 2. 0.5 into 10 power 6. Nothing but 5 into 10 power 5. That's all. The final answer. So for every thing, if it is lengthwise, we need to depend on this box. I'll ask one more question. This question I already asked in last class. Please try to answer. There is a note like this. We apply force in this direction. Force is 20 Newton acting at an angle of 30 degrees. Okay, this area is given. This red color part is given. $20 meters, or its radius is given. Two centimeter. Okay. My question is find stress. Find strain. Also given for this rod, capital E is 5 into 10 power 4 Newton per meter. Newton per meter. Okay. Come on, all of you please try this. Okay, fine. Again, here, if you look here, what is stress formula? Force by area. Stress is force. Okay. Area. Now tell me, what is force acting? Which value should I substitute?
20 cos theta.
Very good, very good. Right. Because if we take this part, 20 is inclination force. Any inclination is a combination of horizontal, vertical, right? So I can resolve this into horizontal and vertical. Right? This horizontal is nothing but 20 cos 30. Vertical is 20 sin 30. The 20 sin 30 is nothing but 10. 20 cos 30. Cos 30 value is root 3 by 2. That is 20 root 3. This value will be 20. 20 root 3. Okay. So in place of stress, which value should I substitute? Always take perpendicular component. So let me redefine this basic definition, basic formula of stress. What is that? Perpendicular force by area. That is very important. Stress is not force by area. Perpendicular. Yaருக்கு perpendicular? Area on which force is acting. அந்த ஏரியாக்கு perpendicular. இப்போ இந்த ப்ளூ கலர் இருக்கா அது perpendicular கிடையாது. Black கலர் தான் perpendicular. Red கலர் ஏரியாக்கு black is perpendicular. அப்போ ஃபார்முலா சப்ஸ்டிட் பண்ணுங்க. Stress equal to perpendicular force 20 root 3 divided by what is area? Area of the circle. இந்த shape எப்படி இருக்கு? Circular இருக்கு இல்லையா? So area of the circle pi r square. That also please remember.
Yes, sir.
Area of circle is pi r square. Okay. Pi symbol will be like this. தெரியும்ல pi r square. Okay. So இங்க போடுங்க pi r before substituting convert this into meters because எல்லாமே SI யூனிட்ல இருக்கும். Okay. So 2 into 10 power minus 2 meters. அதுக்கு square point. That is 4 into 10 power minus 4. Solve பண்ணனுக்கு answer. That's all. Solve பண்ணுங்க answer. The second question.
Sir, cos 30க்கு root 3 by 2 னு substitute பண்ணக்கூடாது.
அம்மா
Cos 30 root 3 by 2.
okay. Root 3 by 2. அப்ப இது 10 ஆகும் கரெக்ட்டா?
Yes.
Yes, you are right. Ten root 3 by 4 pi into 10 power minus 4. Substitute பண்ண ஆன்சர் வந்து இப்போ அந்த கிரீன் கலர் இருக்கா that is 10 by area அது along the area, black perpendicular to the area, 20 inclined to the area. So now we come to know there are two components. One is along the area, second one is perpendicular to the area. This green color is along the area. Black color is perpendicular to the area. Okay. Along the area, we have different names. இன்னொரு பேர் தெரியுமா? Parallel to the area. இன்னொரு பேர் தெரியுமா? Tangential to the area. எல்லாம் ஒண்ணுதான். Tangential means along the area. இன்னொரு பேர் தெரியுமா? Sharing area. Acha. Now there is a new definition for stress. Stressல இப்போ நமக்கு ரெண்டு விதமான ஸ்ட்ரெஸ் இருக்கு. Now stress I have two types. One
Longitude.
is perpendicular to the area. Second one is parallel to given area. Parallel to the given area. Okay. The stress which is perpendicular to the given area is called longitudinal stress. இதுக்கு இன்னொரு பேர் இருக்கு, normal stress. Both are same. Stress which is parallel to the given area, that is called tangential or shearing stress. Okay. இது மாதிரி இன்னொரு ஸ்ட்ரெஸ் இருக்கு, அது என்ன? Volumetric stress that acts along the volume. That stress is called bulk stress or volumetric stress. Volumetric or bulk stress. That's all. These are types of stress. We have 3 types of stress. These are 3 types of stress.
Sir,
Yes.
compressive stress irkada, sir?
Compressive stress and tangential stress comes under longitudinal.
Okay, sir.
அது இந்த இது கீழே வந்து அதோட மீனிங் என்னன்னா, ஒரு ராட் இருக்கு, நீங்க ஃபோர்ஸ் இப்படி அப்ளை பண்ணுங்க, இந்த பக்கம் இந்த பக்கம், அப்போ length of the rod will increase. Length will increase, that is called elongation. The type of force and stress is called tensile. Force applied is tensile force. Stress is tensile stress. இதே மாதிரி இங்க பாருங்க, ஒரு ராட் இருக்கு, I'm applying force like this. Now what happened? Length will decrease. It is called compression. That force is called compressive force. Stress is called compressive stress. That's all. It comes under normal or longitudinal stress. So these are 3 types of stress. Right? இப்போ நமக்கு 3 types of stress கிடைச்சதா? Obviously 3 type of stress இருக்கும்போது 3 type of strain இருக்கும், 3 type of modulus இருக்கும். Right? So how many types of stress are there? 3 types. What they are? Longitudinal, tangential, volumetric. Another name, normal, shearing, bulk. So what is the representation? They represent with the letter E. Okay, I'll give like a table. Okay, so as of now, this is the entire thing. Types of stress and types of strain modulus. You know, this is the main part of the entire chapter for 50% இதுல cover ஆயிடும். Okay, so நல்லா ஞாபகம் வச்சுக்கோங்க. Anyway, I'll send this PDF, you don't worry. பாருங்க. Let me make a table kind of thing. So இங்க longitudinal போடுங்க. அதுக்கப்புறம் ஷேரிங் போடுங்க.
சரி
அதுக்கப்புறம் வால்யூமெட்ரிக், பட் பல்க். இன்னொரு பேர் டான்ஜென்ஷியல். இதுக்கு இன்னொரு பேர் நார்மல்.
நான் ஓகே. First, we start with the setup, that is diagram. The diagram எப்படி இருக்கும்? இல்லை முதல்ல ரியல் லைஃப் அப்ளிகேஷன் பாருங்க. அப்போ உங்களுக்கு ஒரு கைண்ட் ஆஃப் இன்ட்ரெஸ்ட் வந்துடும். இல்லைன்னா அப்படியே டெக்ஸ்ட் புக் படிக்கிற மாதிரி. See, these are all real life examples. For a simple example காக தேடிட்டேன். I guess this is okay. To clarity, I mean, this will be having more clarity, right? Either normal or longitudinal. Okay. Shear examples சொல்லுமா? வெல்டிங்ல வந்துடும் ஷியர், ஆர் ஈவன் மவுண்டன்ஸ், ஹில்ஸ், அதுல ஷியரிங் வந்து. ஆர் கேக் கட்டிங். Cake cutting also best example for the shearing, or bread slice. Easier புரிய வைக்கிறதுக்காக சொல்லிட்டு இருக்கேன் இது. This is best example for shearing. Okay. Next, volumetric. Balloon or some kind of sphere, if we compress from all sides, that is volumetric, right? Or simply you can keep sphere. If I compress a sphere from all sides, like this, these are three real life examples where we use longitudinal stress, shearing stress, and volumetric stress. Okay. Now, our textbook diagram. Textbook diagram will be like this. If I take a rod on applying force on some particular area, so this is the rod. This area I'm applying force. See the textbook diagram. Area on which you are applying force is A. அப்போ இதுக்கு textbook diagram இப்படி இருக்கும். There is a cube. I'm writing on 2-dimensional. Let us consider a point here. If I apply a force, right? In the point இங்கிருந்து இங்க transfer ஆகும், shift ஆகும். இங்கிருந்து இங்க வந்துரும். Point ஓட initial position, point ஓட final position, right? இதெல்லாம் fix பண்ணிட்டு இருக்கேன். This is fixed.
போட முடியாது இன்னைக்கு ஞாயிற்றுக்கிழமை.
Yes, all of you, please keep yourself silence. Vishwanti or something. No? Please make yourself mute. Okay. See, if I apply force, this red color point will jump from here to here, keeping base fixed. Right? Now, if I join this initial and final points like this. Like this. Okay. இது theta. இது h. இது dx. Okay. If I make a right angle triangle like this, now both are same. I will represent here theta dx, so called h. Okay. If I write now tan theta, tan theta will be dx by h. Okay. This tan theta is called as shear strain. Keep it in mind. Because what is strain? Change by original. Because of application of force, what is the change? Red point is coming from here to here. Other change dx. I am taking original reference datum height h. That's all. So tan theta is equal to dx by h. That is shear strain. Okay. So what is shear stress? If I keep this as force, this force is acting along the area. Yeah. Where is area? If you want a 2-dimensional diagram, I draw here. See, that will be like this. On this, some force is acting like this. This force is parallel to the area. Okay. So I can define stress as parallel force by area. But here, what is stress? Perpendicular force by area. Here, stress is parallel force by area. Here, stress is pressure. Call it as pressure. Because same pressure I am applying from all sides. Okay. Now here is strain. What is changing here? Length is changing. So change in length by original length. Okay. Here strain. Change is dx. Original difference x. This is the strain. Shear strain. This is longitudinal or normal strain. Aprom inga. In the change the volume change. Change in volume by original part. That's all. Right. If I do stress by strain, I get this as modulus. So here stress by strain is modulus. That modulus is called Young's modulus. Okay. Here stress by strain is called modulus. That modulus is called shear modulus. Here stress by strain is called modulus. That modulus is called bulk modulus or volumetric modulus. That's all. The tables are ரொம்ப important. Okay. So first one is real life example. Second one is textbook diagram. Next thing is stress formula. Next thing is strain formula. Next thing is modulus formula. That's all. This table is very important. I'll send this PDF to you. Try to by heart this because in solving numericals, this is very important. Okay. And also if I rearrange, I'll get a new formula. DL is equal to FL by A. If I rearrange all these three, I'll get a new formula. DL is equal to FL by E. What is that? Change in length is equal to force applied into original length by area into Young's modulus. That's all. Okay. This entire table is very important in understanding the entire concepts of this chapter, properties of solids. Out of 28 chapters, this is one of the easiest topic. So please pay more attention on it in solving numericals. Okay. Next thing is Poisson's ratio. What is Poisson's ratio? Poisson is scientist name. Poisson is scientist name. Take a rod.
Relative contraction, relative expansion.
Yes, correct. They take this rod. I'll fix here. I'll fix here. We apply force here. Okay. So here two things will happen. Two things will happen here. When first length will increase. Second, diameter will decrease. Length increases, diameter decreases. These two things will happen. Right. So Poisson was the first person who said we need to consider both in design parameters. Random effect of rod. Many years we didn't consider this. Other than negligible, but he said no, we need to consider that also. இதெல்லாம் எதுக்கு for suppose you are using a lift or escalator. நம்ம லிஃப்டோட working எப்படி தெரியுமா? இங்க ஒரு புள்ளி இருக்கு. Okay, one rope. Here one pulley. Rope இப்படி. That's all. இது லிஃப்டோட working. If you go inside the structure of lift, it will be like this. This is simply pulley and rope arrangement. Right. So if this rope is moving like this, lift will go up. Rope is moving like this in opposite direction. இந்த rope அப்படியே கீழே வருது. அப்போ lift மேல போகும். rope மேல போகுது. lift கீழே வந்துடும். That's another principle. இதெல்லாம் இப்பயே சொல்லிட்டு இருக்கேன். இந்த rope இருக்கா? அது எந்த மெட்டீரியல் யூஸ் பண்ணணும்? எந்த ஏரியா யூஸ் பண்ணணும்? How much radius we need to keep? அதெல்லாம் depends on diameter. So நான் force apply பண்ணும்போது force என்ன யாருங்க? Human beings who are standing here. நான் force apply பண்ணும்போது length increase ஆகும். யாருது? rope. Diameter decrease ஆகும். Definitely I need to consider both. Poisson was the first person who said both we need to consider, and is given one ratio that is called Poisson's ratio, which is like this. Representation is mu. Formula is lateral strain by linear strain. Lateral strain by linear strain. That's Poisson's ratio. This is what Poisson's ratio. Okay. இதோட வேல்யூ எப்பவுமே less than 1 இருக்கும். This value is always less than. Keep it in mind. Poisson's ratio value is always less than. Keep it in mind. ஒரு நிமிடத்தில் பண்ணலாமா? There is a rod. Whose length is given, say 4 meters. Radius is given, say 1 centimeter. Applied force is given, say 10 Newton. Okay. Young's modulus is given 2 into 10 power 8. Young's modulus 2 into 10 power 8. length is given, so force is given, radius is given. Now I need a okay, change in radius is given. After application of force, what happens? Length will increase. Once I apply the force, it will become like this, right? What happens here? Radius decreases. The decrease in radius is given 0.2 centimeter. Now I'm in need of Poisson's ratio. Come on, find out. Can I know Poisson's ratio? That is a formula. This is given situation. I'm in need of Poisson's ratio. Come on, try to find out. Formula. What is Poisson's ratio formula is given here? Lateral என்ன meaning என்ன தெரியுமா? Perpendicular. Linear means along the axis. அதான் meaning. Linear means along the axis. Lateral means along perpendicular. இப்போ நான் force apply பண்ணும்போது length will increase along the axis. Radius will decrease along the perpendicular. Okay? இதெல்லாம் புரியலையா? Directly remember a formula like this. நம்ம lateral strain ஓட meaning என்னன்னா dr by r. Very good. Linear strain ஓட meaning என்னன்னா dl by r. dr by r. Okay? Substitute பண்ணா ஆன்சர் வந்துரும். That's all. எப்படி dr கொடுத்திருக்கு பாருங்க இது தெரியும். r கொடுத்திருக்கா? Yes, 1 cm. இதுவும் தெரியும். அப்புறம் dl தெரியாது. L தெரியும். dl எங்க இருந்து வந்தோம்? We have formula dl is equal to FLP. I can find dl
because I know F இங்க இருக்கு. I know L இங்க இருக்கு. I know area pi r square எல்லாமே இருக்கு. So இதெல்லாம் சப்ஸ்டிட் பண்ணா எனக்கு dl வந்துரும். அது இதெல்லாம் சப்ஸ்டிட். That's it. You'll get Poisson's ratio. This is the way how to solve Poisson's ratio. Okay, next thing. Next concept is there is a rod. If I apply force, what happens? First part is length increases. Next part is radius decreases. Third part is it stores energy. The stored energy the strain energy சொல்லுவாங்க. Strain energy example வேணுமா? A stretched rubber band. Rubber band நீங்க stretch பண்ண அப்படியே ரிலீஸ் பண்ணுங்க.
திருப்பி அது நான் ஒரிஜினல் பொசிஷனுக்கு வந்துரும் சார்.
அது வந்துரும். That is called elasticity. நான் சொல்றது என்னன்னா அதுல எனர்ஜி ஸ்டோர் ஆகும். So stretched. Or spring also best example, right? Caterpillar, very good example for strain energy. Right? Caterpillar is rubber band, right? See, this person is doing something like this. What he's doing, he's stretching the rubber band and releasing. Then what happens? It is pushing this object forward, right? So this will push this object in this direction. Then what is happening? Force and distance, nothing but work. Work is happening there. Force into distance, work done. Right. Work is brother of energy. We already learned in work energy power. So what happens here? Energy stored inside the rubber band. Every when you stretch it, சும்மா அந்த rubber band அப்படியே போடுங்க, object move ஆகாது. If you stretch the rubber band, அதுக்குள்ள energy வந்துரும். That energy will kick the object forward, right? And the strain energy ஓட formula என்ன? Strain energy stored formula என்ன? Half into stress into strain into what? The formula. This you keep it in mind. The strain energy ஓட formula half into stress into strain into what? Okay. Unit என்ன வந்துரும்? Joules, because energy unit is joule. Check பண்ணலாமா? Half no unit. Strain force by area. That is Newton per meter square. Stress, right? Newton per meter square force by area. Strain, no unit. Volume,
Volume is area into length or meter cube. Meter cube. Right? If I cancel this, I'll get Newton meter. Nothing but joule. Okay. So unit of strain energy is joule. Okay. இது derive பண்றது easy தான். Is a 4 marks question for your board exam or CBSE exam, whatever it may be. Okay. It will be like, integral FDX போடுங்க. We have DL is equal to FL by area. அதுல இருந்து F வேல்யூ சப்ஸ்டிட் பண்ணிட்டு இன்டிகிரேட் பண்ணுங்க ஆன்சர் வரும். ரைட்? or அதோட ஈஸியா சொல்லட்டுமா? What is the force in a spring? F is equal to kx. Kx போட்டு integration போடுங்க ஆன்சர் வந்துரும். Right? That derivation part I am not doing here. So for final formula is half into stress into strain into volume. What is that? Energy stored in object upon applying force. The formula. Okay. Take a problem. By 10 minutes we'll close the session. Be happy. Length of rod is 5 meters. Diameter is given 1 centimeter. Young's modulus is given 2 into 10 power 5. Change in length is given 2 meter. Find energy stored. Find energy stored. The question. Come on, right? Next week I'll come with worksheet without discussing all these concepts and formula. Directly we'll do numericals next week. Okay. So please refer all these basics and formula so that next week numericals you can easily understand. Formula is half into stress into strain into volume. Stress because stress is force by area. Force is not given. So I cannot find stress. But strain I can find. Yeah. What is strain? DL by L. DL தெரியும், L தெரியும். That is 2 by 5. That's strain. Strain க்கு இது தெரியும். What is volume? Volume formula is area into length. Volume unit in meter cube. Meter cube can be written as meter square into meter. That is area into length. Okay. அப்புறம் stress எப்படி வந்துரும்? Stress by strain is equal to Young's modulus. Therefore, stress is equal to strain into Young's modulus. That's all. Strain தெரியுமா? தெரியுமே. So force area கொடுக்க தேவையில்லை. Strain 2 by 5. Young's modulus தெரியும். அதுல இருந்து stress பண்றோம். Okay. இப்போ எனக்கு ஸ்ட்ரெஸ் வந்துச்சு, ஸ்ட்ரெயின் இருக்கு, வால்யூம் இருக்கு, இன்டு ஹாஃப் போடுங்க, ஸ்ட்ரெயின் எனர்ஜி வந்துடும். தட்ஸ் ஆல். நெக்ஸ்ட் இன்னொரு 2 கான்செப்ட்ஸ் இருக்கு, அதோட சாப்டர் க்ளோஸ். நெக்ஸ்ட் வீக் வில் டூ மோர் நியூமெரிக்கல்ஸ், தென் வில் ஸ்டார்ட் ஃப்ளூயிட்ஸ் டாபிக். ஓகே. Stress versus strain curve. Stress versus strain curve என்ன தெரியுமா? ஒரு ராட் இருக்கு. ஃபோர்ஸ் அப்ளை பண்ணிட்டு என்ன ஆயிடும் தெரியுமா? இந்த ராட் அப்படியே பெருசாகும். அதுக்கப்புறம் இந்த ராட் இப்படி ஷிஃப்ட் ஆகும். அதுக்கப்புறம் நீங்க ஃபோர்ஸ் ரிலீஸ் பண்ணிடுங்க, மறுபடியும் இப்படி வந்துடும். அதான் எலாஸ்டிசிட்டி. ஓகே. Again I am applying force. Then what happens? It happens like this. இது இப்படி ஷிஃப்ட் ஆகும். ரைட். இது ஃபிக்ஸ் பண்ணிட்டேன்னு வச்சுக்கோங்க. Or else you can assume like this. இது ஃபிக்ஸ் பண்ணிட்டேன். I'm applying force like this. ரெண்டு பக்கம் அப்ளை பண்ணிட்டேன். அப்போ ஃபர்ஸ்ட் இப்படி ஆயிடும், அதுக்கப்புறம் இப்படி ஆயிடும், நெக்ஸ்ட் இப்படி ஆயிடும். இப்படி ஆயிடும். நெக்ஸ்ட் உடஞ்சி போயிடும், பிரேக். Like this. Okay. இது இப்படி ஆயிடும். These are different steps how a rod will break. இது ஒரிஜினல். இது broken part. Okay. Original and broken part. If I draw a diagram between stress and strain, அந்த diagram எப்படி வந்து தெரியுமா? இப்படி வரும். ஃபர்ஸ்ட் ஸ்ட்ரைட் லைனா வந்துடும், அதுக்கப்புறம் கொஞ்சம் இப்படி கர்வ் வந்துடும், அதுக்கப்புறம் லைன் இப்படி வந்துடும், இப்படி போயிடும். This is called stress strain curve. Right? So in any graph, y-axis by x-axis gives you slope. Here y-axis by x-axis is stress by strain. So slope of stress by strain gives you theta, but because stress by strain is modulus. இது எதுக்கு இந்த கிராஃப் எதுக்கு? To find modulus. Modulus எதுக்கு? அது வச்சுட்டு we can say whether material have high strength or low strength. அதான் main use of this stress strain curve. The main use is to find modulus. Modulus எப்படி வந்துரும்? Y-axis by x-axis. To find modulus of a material. Modulus is stress by strain. In this graph, y-axis by x-axis, that is theta. Okay. ఇందులో రెండు పాయింట్ జ్ఞాపకం ఉంచుకోండి. If it is brittle material, this is for brittle material. Brittle material is like papad, appalam, chalk piece or applaud example of brittle material, right? So if it is ductile material, it's like steel, bubble gum, ductile material which can elongate more. அதோட கிராஃப் இப்படி இருக்கும். brittle material இப்படி இருக்கும். Okay, elastomer சொல்லிட்டு ஒன்று இருக்கு. If the relation is y is directly proportional to x square, that is called elastomer. அதோட கிராஃப் இப்படி வரும். இருக்கிறது 3 தான். இது 3 ஞாபகம் வச்சுக்கோ. Stress strain graph for ductile material இது, brittle material இது, elastomer means polythene cover, elastic plus polymer. elastomer ஆன polythene cover. அதோட stress strain graph இப்படி எல்லாத்துல y axis stress, x axis. Okay, last point to be noticed is area under entire curve is called toughness. The entire area பாருங்க, that area is called toughness. Okay. Area till elastic point is called resilience. இதோட இந்த கிராஃபோட பார்ட் இப்படி இருக்கா? இதுல if you consider area till this, that is called resilience. Area till elastic point is called resilience. No technical thing. Area till elastic point is called resilience. Okay, this is entire story of stress strain curve. You know, in your textbook they mentioned like this. The origin in the point irka elastic point, இது proportional limit, இது elastic point, இது yielding point, ultimate point, breaking point. அது எக்ஸாம்பிள் எழுதுறதுக்கு ஈஸியா ஞாபகம் வச்சுக்கிறதுக்கு. இது breaking point, மேல இருக்கிறது maximum point, அது ultimate point. அங்க இருக்கிற ஸ்ட்ரெஸ் ultimate stress. இந்த பாயிண்ட் இருக்கா, that is called yielding point. Okay, இந்த பாயிண்ட் இருக்கா, that is called proportional point. Proportional point யாரு, இது. Okay, so in the point elastic limit, the green color இருக்கிற point elastic limit. Okay, This is entire stress strain curve. Right? So with this, we can close the session. I will send this PDF to you all. Please follow this. Next week we'll do numericals. If time permits, we'll start fluids. Right? Thank you all. Bye. Good night.
Thank you.
Thank you, sir.
Thank you, sir.